Okay, we're getting into our work here on composing functions. Okay, so we would like this color. So we know that functions can be defined in such a way. This is a linear function, is a function, and we know how to operate under these sort of conditions. If this is my function and I give it an input value of 2, then I simply need to multiply 2 by 2, subtract 1, get 3. Right, if I input a, then I would get 2a minus 1. Whatever I put in here as my input, it is subject to this treatment here in my function. So if I put in f of p squared, then x becomes p squared. You get the idea. Okay, let's say we introduce another function and call it g, and we let that function be x squared. And let's say that we would like to compose these functions. So let's say rather than finding the function value at x2a, what if we want to know the function value is when the g function is 2? So compose the functions f and g such that we find the value of the f function when the g function is 2. So in this case, we are finding out, well, let's have a look at, oops, sorry about that. Let's have a look at, my color's gone. Seriously? Where are they? There they are. Okay. So at G2, I put in 2 here for G, and I get 2 squared, which is equal to 4. So this value here is 4. So I am looking for the value of the f function when 4 is put in. That's 2 times 4 minus 1, which is equal to 7. So f of g2 is equal to 7, and this is sometimes written, you'll actually very often see it as f of g2. That is the same as f of g2. This is the way we like to look at it. That makes a lot more sense, but you will see this sort of notation. So being familiar with that is important. Okay, so let's get a little bit more practice at this idea. Let's say we go in the other direction and we want to find out what g of f negative 1 is. So what that says is, well, what's g function worth when the f function is evaluated at negative 1? So at f of negative 1, we put negative 1 in here, we get twice negative 1. Negative 2 minus 1 is negative 3, so that value there is negative 3. The g function is worth at negative 3, you square it and you get, so g of negative 3 is equal to 9. We can look at defining this algebraically. So we can look at defining f of gx in algebraic sense rather than just at a specific value. So we would look at doing so by replacing gx with x squared. So we're putting x squared into the f function, which simply means we put in x squared into this spot here, and we get 2x squared minus 1 as our solution. So this is our algebraic definition for f of gx. And we could define it the other way, g of fx, and that would look like g 2x minus 1, and that is putting 2x minus 1 in here and squaring it, 2x minus 1 all squared. So if you like, if you're looking at this another way, we have, let's go back to this example here. This is the same as taking an input value of 2, putting that into the G function, taking the result, the output from that, which was 4, and putting that into the F function. So providing the output of the G with as the input of the F, and then out came the result. So what happened here, when 2 went into G, the output was 4. When 4 went into F, the output was 7, and that was our result right here. So that's pretty much how composite functions work. I'll let you do some examples and we'll talk again soon. Cheers.